Hi everyone, welcome to LeetCode Challenge. So today I'm very excited to have first class on LeetCode Live. Abhi I don't have camera for some reasons, some electricity is not there, so sorry for that. So let's start with a LeetCode question. Now what we'll do, see, we'll be taking patterns on LeetCode questions, as in like we'll be taking few questions on a single pattern. So today I decided to have Fibonacci as a base, where we'll be solving many questions on the basis of Fibonacci. So we have many questions like Fibonacci, Tribonacci, climbing stairs, minimum cost climbing stairs, house robber 2. So are you ready for the class? We'll wait for 1 minute and we'll get started with new questions, new strategies, and we'll be taking one question with many of the methods. Like first method will be naive method, then how to optimize it, then we'll be also checking with the complexities, where we'll be checking time complexity, space complexity, everything. And the questions asked in the FANG company, we'll be targeting FANG company, where how to answer there. So that we need to check out. So let's get started. If you have any questions on the way, you can ask me then and there. So if you are okay with it, we can start the class. So let's start with first question, which is Fibonacci LeetCode number 509. So this is our 509 Fibonacci number. Let's read out the question. The Fibonacci number, commonly denoted as Fn, form a sequence called the Fibonacci sequence, so such that each number is the sum of two preceding ones starting from 0 and 1. That is, F0 is 0, F1 is 1. Before attempting any question, we should be knowing what the question is asking. What is the question is all about. So mandatory, if you have been given any questions in the interview, read it out. At least take out the conditions, what conditions they are asking. So here it is mentioning F0 is 0, F1 is 1. So in smaller classes we have already read what is Fibonacci. Fibonacci is all about having the numbers like 0, 1, and then addition of their last two numbers. Okay. Then it says Fn is Fn minus 1 plus Fn minus 2 for n is greater than 1. Given n, calculate Fn here. Let me check if anyone is joining. Okay. So for example, n is equal to 2, it will be giving 1, f2 is equal to f1 plus 0. Okay, fine. So what we got? What is Fibonacci? Fibonacci is all about number game. Let's take it from the basic, like how we are, like we just want to understand everything from scratch. Got it. So what we'll do, what is Fibonacci? It is all about number game. Number game as in which starts with 0 and 1, and every next number will be the sum of last two numbers. So this is 0, this is 1, so last two numbers addition will be 1. Then the next number will be last two number addition 2. Then the next number will be 2 plus 1, 3, and so on. Let's take one more. 3 plus 2 is 5. Cool. So this is a Fibonacci number. Let's understand how, like from the scratch, what will be the naive solution. We'll be asking here again and again. Like here on every point we'll be asking what will be the next number. Like here 5 plus 3 is 8. Then again I am asking what will be the last two numbers addition, which is 13. So this is how the Fibonacci number returns. So somewhere we are getting the idea what we are doing. We are taking the last two numbers addition. So if I have the number n, what we are doing? We are taking n minus 1 and n minus 2, and we are simply adding it up. Cool? Okay. So what is the naive solution? Where we'll be asking again and again. So here if I write it in a proper way, I just need to take return fib, the last two numbers n minus 1 and fib n minus 2. Okay, let's take it the other way. Like let's build a tree also here, because this is a tree based question. Why I said this is a tree based? You will be saying no, this is not a tree based question, it is a recursion question. But let's see how it is built, because recursion is all about trees. That I'll show you. I'll prove my point over here. I'll open onboard. Let onboard open board open, and here we have the screen. Okay, let me cross it over, and okay. So what I'll do, I'll take a number. Let's say I am taking f of 5. Now we have already seen Fibonacci is all about sum of last two numbers. That means if I have f5, n minus 1 and n minus 2. So here n minus 1 will be 4, because we are treating n as 5. And here n minus 1, the second one will be n minus 2. So I have taken f3. Similarly, here also I will take n minus 1, which will be 3, and here it will be 2. Similarly, here also f of 2, and here it will be f of 1. Then again f of 3 will be returning. F of 2, and here it will be f of 1. Then if I see the question here, it has said f of 1, f of 0 is 0 and f of 1 is 1. So we'll take the same thing over here. We need to drop down till we get till we get 0 and 1. So f of 2 will be returning f of 1, and this will be f of 0. We are simply dropping it down, like we are just rugging up. So here also we got f of 1 and f of 0. Cool. And then f of 2 is also having f of 1 and this will be f of 0. Cool. So this is about Fibonacci. Now what I'll do, I need to go up. So f of 1 was 1 as we have seen in the question. F of 0 is 0. So what we saw here, 1 plus 0, we need to do the addition. The same thing I'll do here. 1 plus 0 is 1. So f of 2 we got 1. F of 1 is 1, which is 1 plus 1. F of 3 will be 2. F of 1 is here 1. F of 0 is 0. I'll write here also. And f of 2 will be 1 plus 0, which is 1. Here 1. See, in f of 2 everywhere we are getting 1. F of 2, f of 2, f of 2. Now let's go up. Here f of 3 is 2. Now f of 2 is 1. So 2 plus 1 will be 3 here. Similarly f of 1 is this. 1 plus 1 will be 2. And f of 5 will be 3 plus 2 as 5. Let's check it out. So this is a naive solution. How we got? By just calculating simple values, we just add it and reach to f of 5. But have you seen one condition here? That f of 0 is 0 and f of 1 is 1. In recursion, the must condition is we should be having one base case. If you don't have any base case, it will fail, right? Like here, f of 2 has f of 1 and f of 0. If we don't have any base condition, what it will do? It will be ANDing, and it won't be ANDing. It will be just running again and again, which is not okay for here. So that is the reason in recursion, we should have one base case. So what I'll do here, I'll put one base condition, which we got from the question itself, which is if n is equal to 0, here you can see 0, or n equal to 1, then in that case it will be returning n. So this will be returning the question Fibonacci. Now if I run this, it has said fib. Okay, so in Python we need to follow oops concept. So you need to take care. If you have this self, you need to put here self dot and here also self dot. Let's run these. We see, if you can see here, all three cases are solved. When n is equal to 2, it has returned output 1 as expected, n is equal to 3, and case 3 all ran. Now let's submit it also. As it is a naive solution, there can be chances that it won't be accepting, but here it got accepted. So let's check it out. What will be the time complexity here? Can you guys tell me what can be the time complexity and space complexity? You can comment it down if by any chance, otherwise I'll be also telling. Okay, so time complexity here will be, check how it is dividing here. Here for F5 we have 2 branches, F4 has 2 branches, F3 has 2 branches, right? So we can expect, like, what can be the time complexity? 2 to the power n, because for every branches, for any of the like if you are calculating for trees also, you need to check out how many branches are there. So we have seen here 2 branches are there. So number of branches to the power we are calculating. So here we have n is equal to 5. So 5 times it is making a tree. Hi Karun, hi Neer. Here we are learning all about Fibonacci. We are taking different patterns on every class. So we have planned for 9 p.m. live classes for LeetCode. We'll be taking many of the LeetCode questions at 9 p.m. If you know the questions, we'll revise it. If we don't know the question, let's learn something new. So we'll be having such strategy at 9 p.m. And I'll be taking in this class LeetCode questions, which I am planning. LeetCode questions, LLD concept, some of the HLD concept. We'll be discussing something new at 9 p.m. daily. That's what my strategy is. If you have anything new, like if you want to discuss any question or any concept, please let me know, so that we can have a healthy conversation with like you can also tell your concepts, we can discuss then and there. Okay, so we were discussing about time complexity, how to calculate time complexity for a Fibonacci question. So here we have f of 5 and we can see there are 2 branches coming up. So number of branches to the power number of elements. Since we have n is equal to 5, so we can say 2 to the power 5. So here it is exponential. If you tell in an interview, ma'am, please solve SQL problems in LeetCode. Sure. Let's take some LeetCode questions patterns first, and then we'll definitely take SQL problems as well. If you have any particular question, you can also mention over here. So here we can say time complexity is exponential. Simple. B2B, yeah, topic by topic, I have already taken recursion topic. So I'm planning to have recursion topic, all the, see, not topic to topic, I'm trying to take the questions which are generally asked in the interview. Patterns, basically I am trying to follow patterns on which maximum questions are asked, so that you can have the interview preparation at 9 p.m. That's what my strategy is. If you have any questions, obviously it will be totally on your choice. If you tell me any question, any specific question to be discussed in this class, we will definitely discuss. So hopefully it is clear. Now, as I was saying, time complexity is exponential. And what will be the space complexity? If you can check here, we are following all the n. So here it is order of n, because tree is building itself, like in if we check, tree is built on stacks. So that's the reason it is giving order of n. Hopefully the naive solution is clear. This is also ran. It ran here and we got the we have already submitted the question. Now let's see how we can optimize it. So second way we can say, see, here in recursion we were asking on every point what will be the question, what will be the answer, like here. Let me comment it down, and we are taking 0, 1, which was the base condition, and at every point I was asking what is the next point, next number 1, then what is the next number. We have calculated on every point. Next number is 1 plus 2, which is the addition of last 2 numbers, so 2. Then what is the next number? So at every point I am asking this many times. So this is recursion. Now what I'll do, I need to optimize it. So I'll write it down in a notebook. Let's say here, if you can see, this F2 has been repeated so many of times, right? Here F1, F0 is repeated so many of times. So we can see this is wasting our energy, our time. So what I'll do, I'll put this F2 in my sum of the notebook. I'll write it down. This f of 2 is 1. So that when it comes next time, this here, I need not to calculate again. I don't want, I need to calculate this 1 plus 0, 1 again. Now here I'll be putting this as 1 as soon as I get this f2. If you let me discuss further. Let's say if I took here f5. See, recursion is all about many of the numbers, large quantity, large numbers. Just to understand, we are taking recursion for small numbers. That's why here our conditions are passing. But when we have many of the data, then recursion, if we don't put base condition, there are many errors coming up. So see, here when we have 4 and f3, then again I'll break it down. F of 4 will be n minus 1, which is 3. F of 4 will be f of 2, and similarly we'll have f of 2 and here f of 1. So you can see here this f of 2 is being repeated. So what I want, my funda is like, I need to, whenever I get f2 value, I'll write it down somewhere. That f2 value is something which can be anything. So what I'll do, I'll save it over here, so that when I get the next time f2, I'll take from here and copy its number. I don't want to calculate this number. So we need to act smarter. We just need to write it down in our notebook. So that notebook is all about memoization, where I am putting my data saved, so that when it comes next time, I just need to hand over this value here. I won't be calculating this value again. So that if you need same number, you just peek in your notebook instead of recalculating. So it will be making it faster. Hope this concept is clear. Though we guys have done this question many of the times, but still we need this concept later also. That's why I took this base concept before. Definitely this question is asked in many of the first round of interviews, and whenever we are more confident, then we make mistakes. So hopefully you won't be making mistake again, or we'll be making ourselves confident here. Okay, so this is the first type which we have discussed by naive solution. Now let's build a solution using memoization. So what I'll do, should I write it down here, or let me delete? Okay, let's write again and again. Or what I'll do, I'll save it somewhere. Let's write it down here. Cool. So now we'll see how we can solve this concept using memoization. So first of all, as we have discussed in recursion, we should have some base conditions. base conditions are normally found in the description itself in the lead code. So we need to read question properly for any of the questions which are asked. It can be easier question, it can be tough question, but the must thing, we should read out the question clearly so that we can get answers in the questions. Okay, so let's have a base condition which is if n is n equal to 0, then it will be n only. That means if n is equal to 0, we should have a 0 answer. If n is equal to 1, it should return the same thing. Okay, now what we have to do, we need to save our numbers. So what I'll do, I'll take a dp value and here I'll just write it down -1, and it should be n plus 1 times. Simple. Don't think too much on this, just how we will be making use later. Let's see that. Okay, so here I'll take the help of a helper. Since we are writing in Python and we are following oops concept, so we need to write it down in self dot, and we'll take some dp value and this n value. Here we have taken helper and we'll take dp and n. Okay, now first we need to take this condition. If n is equal to 0 or 1, it should return n. Now we need to check the conditions which we are solving here. That dp of n, we have made a dp a array. Simple, this line simply means that we have a dp variable of an array which has all the -1 of the length n plus 1, and we'll be saving here. What we'll be saving before returning? Let me make the conditions, which is dp of n should have dp of this n. I'll copy here from here itself, or I can take from here, dp n minus 1 addition of last two numbers. So here also n minus 2. So the base condition, now we have taken this dp, the array, the first. Okay, let me show you how we are doing here. Let me add page. Now what I said, I'm taking a array of variable name dp of length n plus 1, so that first value will be 0, then 1. Since we are taking from last, so what I have done, the first value will be n minus 1 and the second value will be n minus 2, so that this value should have addition of these two numbers. Simply I have written this line. So I have taken dp of n minus 1 plus dp of n minus 2. And then I'll return it over here. dp of n. Now we need to also take care that since I'm using the array of n plus 1, I need to make one more condition. If dp of n is not equal to -1, till then it should return dp of n. Simple. So simply what makes this question, this solution, this method different than last one? Here what I am doing, I am trying to make a dp array and I'll save the numbers which are there before and will return then and there. And why I wrote this condition, dp of n is not equal to -1, because since we are making the array here, Now I need to check the last value should be there. If we have last value, then only we can calculate n minus 1 plus n minus 2 value. If this value is not there, then we won't be calculate these two numbers. Simple. So let's try to run this. This is called memoization, where we are saving the numbers and making the use later. Now here it's saying if dp of n is not equal to minus 1. Let's see. If dp of n, we have introduced here dp. So why I am getting this? Any idea? Return n. If dp of n is not equal to minus 1, it should return dp of n. It should not give error here. List index out of range. So list index I have calculated n plus 1. Since it is n plus 1, here we have ndpn. Now n is equal to 0, n is equal to 1. It is returning n. If dp of n is not equal to minus 1, then at that condition it should return dp of n. dp of n not equal to minus 1. Let me check it out. What's the problem here? If n is equal to, if by any chance you guys know, you can tell me where I'm getting wrong. dp of n, list index out of range. Since I have made here plus 1 into n plus 1, dp n minus 2. Let me check out what's the exact problem here. If I check here in submissions, what's the exact problem? Let me comment it down so that we should know what's the problem coming up. Now if I run this, let's index, one second. Let me comment it up. Yep. N. When I run here, so what was the mistake? Minus 1. since we are taking two values, returning n, dp minus 1 into n plus 1, dpn. If n is equal to dpn is not equal to minus 1, it will be returning n. No, returning dpn itself. Dpn has dpn minus 1, dpn minus 2, returning dpn. What's the mistake I am doing here? If n is equal to 0 or n is equal to 1. Let's check it. Let's see. So you guys know what mistake I was doing. Here it was or, because in any of the condition we won't be having AND condition, right? We should have either n 0 or n is equal to 1. Cool. So here also it should be OR itself. Either, for me, why it was failing, because n can be 1 or 0, right? Let me submit it. See, it got accepted. So we have taken the condition of dp. Here we try to memorize it. So in here, what will be the time complexity? Since we are iterating each of the numbers, we are going recursion on each of the number. So it will be calculated as order of n. Since we don't have a tree here, we are making array, we are calculating, we are making an array where the last number will be the sum of last two numbers. So time complexity will be order of n, space complexity will also be order of n, same like before. So can we optimize it more? Or we can say, let's see the other method, how we can solve it. The Fibonacci desktop, yeah. Let me, why it is coming again and again. Description, code. So this is one method. We should, the mistake which I was doing here, it should be or, either n can be or 0 or 1. So hopefully this point is clear, how we can memorize it. Now we'll see the other method, how we can calculate Fibonacci with other method. Okay, so let me write it down somewhere, or I'll take the complete solution and will write it over here. I'll comment it also on the same hand. I'll comment it down. In the meantime, if you have any question, you can ask. Okay, so let me rub it up and let me have the base condition, because we will be needing this base condition anyhow. Okay. So the other way, we'll check it out using iteration. So here we have n is equal to 0 or n is equal to 1, which is returning n. Here we will take again the array of the same -1 value, and its length will be n plus 1. Same like before, we are taking the array here, for which we'll be checking out the first number. We'll take the base value here also. dp of 0 is 0. dp of 1 will be having 1. And we will iterate for I in range from second number, because the first two number we got the value, the first zeroth value, zeroth index should have 0 value, first index has 1 value. Now we'll take from second index till n plus 1, since we have array of n plus 1 length, and here we'll calculate dp of I as dp of I minus 1, since we have 0 and 1 here, we'll be calculating its sum. So 0 plus 1 will be 1. So when we are calculating dp of I, it will be having dp of I minus 1 and I minus 2. Then I'll be returning this dp of n. Let's check it out whether this works or not. We got all cases accepted. Now let's submit it up. It got submitted. Fine. So this is the third way through which we can have Fibonacci. Now, can you tell me like how we can calculate, like what will be the time complexity and space complexity for this solution? Or let's take it the other way. Let me have this solution also put it over here. So we have already seen Fibonacci question which can be solved using 1, 2 and 3 ways. Now what we'll do, I'll take if n is equal to here, and instead of making the array, I'll take one value which is second value as 0 and the last value as 1. And then I'll start iterating for I in range from 0, 1 and the second index to n plus 1. Where I'll take answer is equal to second plus last, and then let me explain you what concept I am thinking of here. Here what I am thinking, one value as, or I'll take the simple value a is equal to 0 and b is equal to 1. Now I'll take one variable where I'll be calculating its sum, which is a plus b. And then what I'll do, I'll pass this b value to answer. And the b has a value, so that when we return the again when we'll do a plus b, we get the answer. Simple. So this is how we can calculate. Here we have second is equal to last, and the first value which is answer will be having will be passed on to last, and then I'll be returning answer. Simple. Let me run it up. Let's know when whether we are doing it right. It got accepted, and here we got, when we submit this, our solution got accepted. So this is the fourth way, but let me tell you what will be this time complexity and space complexity over here. See, time complexity will be same as order of n because we are calculating for each and every number. But if you see, for space complexity, we are not using any of the values, which is say we are not storing anything. We are just making use of values and we are calculating on the fly. So we can say the space complexity over here will be order of 1. So if you can check it out, we have all the solutions optimized. First we have seen recursion. With the recursion way, we had exponential time complexity. Then we calculated the answer using we optimized using memoization, then we saw this method. So total we have used 4 methods over here. So this is the way how we can calculate Fibonacci. Similarly, we have the other question, Fibonacci. The Fibonacci is all about, let me take out LeetCode-509, which is already opened here. Now here, if you check the question, it has T0 is equal to 0, T1 has 1, T2 has 1. And then it is calculating the 3 number. So if you see this question properly, you have all 3 values 0, 1, 1. Yogesh, you asked, are you a student? No, I am not a student. I am a working professional. Since I have practiced this in my college days, so I can explain here. So here it is similar to Fibonacci. So if I have this question already written, see, you can see Fibonacci. Let's check it out, the base conditions. What is the base condition? 0, 0th value is 0, 1 value is 1, and second value is also 1. So just we need to add one more OR condition where will we have if n is equal to 2. But for n is equal to 2, it is returning 1. So I can't add here this. I need to add on one more if condition. Let me copy this line here and I'll open the LeetCode so that will be confirmed whether we are doing the right question, right answer, or we are able to solve this question or not. So here I'll add more if where we'll be having n is equal to 2, then in that condition it should return 1. That's what the question is saying. And here I need to return plus self n minus 3. Let's run it up. Here we got the condition wrong. Return self.fib is has no attribute fib. Okay, sorry. Here we are using Fibonacci. Let's run it again. All conditions got accepted. We'll submit the solution. See, it's taking more of the time. Why it is taking more of the time? See, time limit exceeded. Because there it was 2 to the power n. Now if you see this open board, let me come up to the first page. Here we had 2 branches, but for Fibonacci, what will be the condition? It will be having the 3 branches. So if you calculate time complexity here, it will be 3 branches to the power n, right? So you can calculate here time complexity easily. Space complexity will be same order of the n, because we are storing each of the value. So similarly we can calculate for more of the values, like here Fibonacci we have used n is equal to 0. We'll be making dp for this also. Let me take it up. Let's run it. Just we'll run here. If n is equal to 1, n is equal to 0, return n is equal to 2. It will be having return 1. Will be making dp array. So basically it's same as Fibonacci. Shift up. So helper, help me. Just I need to add this for n minus 3. I need to write n minus 3, and also I need to write this condition. Let's run it up. Or condition is there. Okay, now when I run here, the solution got accepted for all of the cases. When I submit it, it got submitted. So here the time complexity is saved because we are making the array. Since we are making the array here and making use of this, then or time complexity will be order of n, and space complexity will be also be order of n. Similarly, we can solve for this also. Here I just need to add dp of 2 is equal to 2. Sorry, dp of 2 is equal to 1. So this is how we can solve Fibonacci and Fibonacci. Let me run this also. Since we have already written Fibonacci, we should be aware how the question is being solved. So see, I have shown you everything here, how we can make use of Fibonacci, and then we can write the question. We can solve it using Fibonacci and Fibonacci. Tab. If n is equal to 1, n is equal to 2, return n. Similarly, I can take for n is equal to 2, n is equal to 2, it will be returning 1, and we'll be having dp minus 1, here 0 for 0, for 1 it will be 1, and for dp 2 is equal to also 1. Then we'll be having the iteration, and here it will be taking from 3 onwards because 0, 1, 2 is taken, n plus 1, and also will take for dp I plus I minus 3. Let's run it here, and when I submit this, it got accepted. So here also time complexity will be order of n. So now it's going to be 10. I thought to cover climbing stairs also. See, there are many patterns to every questions. So here we have Fibonacci. With the help of Fibonacci, we have calculate Fibonacci. In climbing stairs, this question has been asked in make my trip, which is similar to Fibonacci, where we just need to make a dp and we need to calculate just the solution which we have discussed in Fibonacci. The small thing which makes it different there, that each time you can either climb 1 or 2 steps. So here we won't be taking 0th value. We don't need to take any 0th value. We just need to take 1 value and 2 steps. For dp, like if any 1 step, if n is equal to 1, it will be 1. If n is equal to 2, it will be returning 2 itself. So same solution it will be taking for climbing stairs also. So today's agenda was to discuss many questions on Fibonacci. Tomorrow at 9 p.m. we will be discussing the next questions. The other thing, maybe it can be, you can tell me, you can ping me up. I'm also available on Instagram. There are many, we have a Netsetos site. You can find, I'm available on YouTube. If any of the problems comes up or any topic you need to discuss, you can tell me or ping me up. So let's meet tomorrow at 9 p.m. sharp with a new LeetCode question, and I'm also planning to have weekly insight, like we have weekly question contest going on LeetCode. It always have weekly contest questions, so we'll be discussing on every night that particular questions. Okay then, thank you. Let's meet tomorrow at 9 p.m.